All right, my friends, let's look at problem 6 here. It says if f prime is a continuous function for all real x, then what the heck is the limit as h approaches 0 of 1 over h times the integral from a to a plus h of f prime of x dx. So for this problem, it's actually going to fall into your lap pretty quickly if you just work from the inside out. So starting with this integral expression right here, just apply the fundamental theorem of calculus to that little piece. And then if you bring the rest of the notation down around it, things are about to fall into place. So antiderivative of big F prime would be big F. And then let's plug in the upper bound. So big F of a plus h minus big F of a. And then from there, you could just kind of maybe add a little cosmetic change here, where you, instead of writing times 1 over h, you have this expression here, all over h. So you'd have big F of a plus h minus big F of a all over h. And then this is your moment to see if you have been sufficiently tortured with the definition of derivative. This is the definition of derivative of the function named big F. And then instead of being the general derivative at x, it's the general derivative at a. So in this case, it would be f, big F prime of a, which matches up with e. All right, let's look at problem 8. Problem 8 works you a little bit harder. Problem 8 is actually an improper integral. Let's make sure that you're okay with why. The given integral could be thought of in this way with the dx pulled off to the side. And then if you think of the graph of this function, it would have a vertical asymptote at x equals 1, which lies between 0 and 3. So a problem like this, you actually need to split into two integrals. So you'll evaluate up to the left side of the vertical asymptote, and then you'll evaluate from the right side of the vertical asymptote and on. So in this case, you would rewrite this as the integral from 0 to 1 plus the integral from 1 to 3 okay. Also worth mentioning is that you will be evaluating the integral from 0 to 1, but you're approaching 1 from the left side here. And then you'll evaluate the integral from 1 to 3, and you're approaching 1 from the right side here. Okay, so how you evaluate these is up to you as to how much fancy notation you want to use or not. If I suppose your AP exam won't have a multiple choice section, but if it did, no one would care about your notation. Maybe I should behave myself since you guys don't have a multiple choice section. So maybe I should be more careful with my notation from here on out. But anyway, one thing I'd like to do, since there's some repetitive nature here with the antiderivative piece, is I think I would probably do that as some scratch work off to this side. So I'll just kind of like make room for that here. So I'll just do an integral without bounds. So to do this, you could be kind of careful and let u equal 1 minus x. Notice your du then would be negative dx. So this would be the same as the integral of a negative 1 over u squared du, which would be, that's like u to the negative 2. So add 1 to the exponent, you get negative 1, divide by the result, so the negative gets canceled out. So you end up with, and there'd be a plus c, but all these have limits or bounds on them, so you wouldn't have to worry about that. Okay, actually, one final step, let's back substitute. So this would equal 1 over 1 minus x. There we go. Okay, so bringing that back into our problem, our first integral could be thought of as the limit as b approaches 1 from the left and we would have already have figured out the antiderivative is 1 over 1 minus x. So like that. Plus the limit as a approaches 1 from the right of 1 over 1 minus x from a to 3. Okay, so from here, let's see what we've got. We'd have the limit as b approaches 1 from the left of 1 over 1 minus b. I'll just kind of, and then minus, let's see, 1, it looks like. Okay. Plus the limit as a approaches, actually, let's plug the 3 in first. Okay, so what is that, negative 1/2? And then plus the limit as a approaches 1 from the right of 1 over 1 minus a. There we go. Okay, let's look at these limits really quick. So we'd have 1 over 1 minus this number approaching 1 from the left, so a 0.99999 situation. So what would that be? 1 minus a number that's not quite 1. So we'd end up with 1 over a little tiny positive number. And then minus, these group up to be 1.5. And then here you'd have plus, wait, plus? No, minus. Oops. It was about to get confusing. Okay, so then minus, and then if you put the number a little bigger than 1 here, you'd end up with a number a little smaller than 0. Okay, so now what do we have? We have positive infinity, take away 1.5, and then you're subtracting a negative infinity, so you're adding positive infinity. So it looks like this thing blows up to infinity, which is why we could say that it's divergent. I hope this helps you guys. Take care, everybody.